Hello, everybody. One more day. So we're going to talk about something really exciting again that we're working on and that we want to share with you. And the goal is to improve how Liferay can be used as a headless platform. Many of you might already be using Liferay as a headless platform. Actually, we've seen several talks during the event about it. Yesterday, I was mind blown by one talk about how they are using Liferay as a headless platform to serve data to a VR system, right? Virtual reality system. It's really, really powerful. But we want to talk a little bit about some improvements that we're doing for future versions of Liferay. So first of all, let's make clear what headless means. Headless means is using a software without using its UI. That's all it means. It's pretty simple, okay? So why is it important to support headless? Why is it important to continue improving the usage of Liferay as a headless platform? Okay, so in the keynote, Jose Navarro already talked a little bit about this. First, we started moving from just one single device, which was the computer, the desktop computer, maybe the laptop, to mobile phones, to tablets. But now that's increasing to many more devices, many more types of devices, and that means also many more types of applications. It's no longer just a matter of adapting your application, but in order to connect a bot or a drone or a digital assistant, then you may need to do something very specific for them. Okay, so that's where APIs make a lot of sense, and using Liferay as a headless platform to be able to reuse all of that functionality is more important than ever. In fact, there is even a term for this, right, which is the API economy. The API economy, basically what it means, or the way I like to think about it, is when you just not only expose the API so that you can build applications on top, but when you open it up so that other people can also do it. So who are these other people? Who are we giving access to our API? So basically there are three levels. The first level is the private. The private is when it's just internal teams. The second level is what is called the partner. So basically, it's trusted companies. Only trusted companies you have a relationship with may use your API to build additional tools. And then the third level is public. I make it public so that anyone who wants, they may have no relationship with me other than filling a form online, may be able to build their own tools. So we've all used applications like Facebook, like Twitter, like many others, which have an open API, a public API, and we might have even used applications built by third-party developers we don't know about, and Twitter, Facebook, etc. don't know about. That's a public API. So what is important to understand and to keep in mind is as we move outwards, two things are increasingly important. First, security and control of how that API is being used. And second, change management. Dropbox, yes, decided to take away their version 1 of their API after 6 years. They had to keep it for 6 years when it was no longer the last version of the API, because otherwise they would break a lot of things. And guess what? They're still breaking clients out there. So change management is more important than ever if you are opening up your APIs more and more. So what does Liferay offer today? So on top of this modular platform, we actually have several types of APIs. So first, we have the JSON Web Services APIs, which have a lot of great characteristics. They are auto-generated, so they are very comprehensive because it's so easy. They are featureful, they are efficient. They follow a design architecture, which is RPC, Remote Procedural Call, and then they are coupled. Being coupled is a key thing here. That has good and bad things. The good things is if it's the same team doing both internal development and using the APIs, it's great because you already know the APIs. So you just use the same API. You know about it. But if it's separate teams or they don't even know about you, then that might be problematic. So that's why in 7, in Liferay DXP, we introduced JAX-RS, which is a standard way of creating your own APIs in any way you want, right? It's a standard, it's very flexible, allows building RESTful APIs and leverage those characteristics. And we have also some security capabilities, such as Liferay's permission system, some basic authentication, and some basic controls of the APIs. So how can we improve? We can improve in 2 ways. The first way is improving in these security and control capabilities. And to talk about that, I'm going to hand it over to Stian.
Thank you, Jorge. So security and control in the context of a headless platform can be broken down into 3 main requirements: authentication, authorization, and what we would like to call service access quotas. Today, Liferay portal provides integration with a large number of SSO solutions and protocols. On one side, you have enterprise options such as LDAP, SAML, CAS, and NTLM. And on the other side, you have social options such as OpenID, Facebook, and Google Login. And as of Liferay Portal 7.1 and Digital Enterprise 7.1, we will also be supporting OpenID Connect. However, the main change to facilitate headless operation is in the area of authorization. So today, Liferay implements authorization through its role-based access control, and that's underpinned by a very fine-grained permission checking system. It's a very strong foundation. But we've identified for headless operation, we need to enable the user to delegate their permissions to third-party apps or devices, because we're all now carrying smart devices around, or we have them in our homes. So we're now working on Liferay becoming an OAuth 2.0 provider. Thank you. The reason for this, the reason for choosing OAuth, as I think that just demonstrated, is because it's a widely adopted web API protocol, and it facilitates multiple authorization granting flows with different device profiles. So we'll be supporting most of these, and I thought it would be useful to go through them from the perspective of a remote app. So let's start with the client credential grant flow. This one's good to start with because it provides an easy migration path from your legacy API authentication schemes, such as BASIC, which is today used by the Liferay API. And it works very simply. All the remote app does is provides its client ID and client secret, which is a username and password, to the API authorization service. And that's exchanged then for an access token, which it will then use to consume the API. Now, the user is not taken into consideration here. So this type of authentication is useful for APIs providing generic functionality, such as looking up addresses from postcodes or zip codes in the States. So let's get a bit more interesting. The second flow is the resource owner credential grant flow. And to illustrate this flow, let's consider a highly successful website that now wants to launch its first mobile app. They've identified that this is the correct flow for them because they want to provide a fully native mobile experience. And the reason this flow is a good match for that is because it expects the user to provide their existing username and password to the mobile app, and then the mobile app exchanges that for an access token with the authorization server. But then this happens. Where are the users? As it turns out, user trust is a very fragile thing. And although the website company were very proud in delivering a very native experience to the mobile app, the first thing the users saw was the potential phishing attack to get their username and password. So this flow is only useful if you've already established a level of trust between the user and your new app. So then moving on to the next flow, which is the best option, I believe, for web server and user agent applications. You'll see examples of this throughout the web. Part of its success is because it does not require the user to provide their username and password to any untrusted entity. And to illustrate this, we'll consider a slightly shady-looking web server, remote web server, wanting access to the Liferay API on behalf of some user. And it does this by issuing a web redirect with a web browser to the API authorization service, and on that redirect, providing its client ID and the redirect URI. Now, this is a sort of public credential for this client. Next, the user authenticates with the API authorization service, not involving the shady app here, and then authorizes the app access. The service then issues a web redirect back to the shady-looking web app with an authorization code that then the shady-looking web app can exchange for an access token through a back channel. So the web browser is highly significant in this flow, and consequently, if you use it for mobile apps, you will be breaking the native mobile experience. Just something to keep in mind, might be acceptable. So can we, Liferay, improve upon this user experience? I think we can. After all, Liferay DXP is all about managing omni-channel touchpoints throughout the user journey. So in the context of API and authorization, we'll be providing pre-authorized tokens for these touchpoints. And this is best explained through an example, I believe. So let's imagine the user arrives at a Liferay web portal to purchase an item. And then upon successfully purchasing that item, the Liferay portal renders a pre-authorized token in the form of a QR code, which a mobile app can then scan using the mobile camera to bring the entire user context across to the mobile device without prompting for further user authentication. So what you've created here is a very slick, very natural experience for the user that feels a bit like this. Very relaxing, very smooth. But we don't have time to relax right now, because I'd like to make the point that for the first time, there's now a super simple way for remote apps to authenticate users using all the available SSO, web SSO solutions, like SAML, OpenID, etc., and then use that authenticated user to access the Liferay API. So I'll leave you to think about what sort of user journeys you can create using these new features, and wrap up my section of the talk by briefly talking about the third headless requirement, which is service access quotas. And this is a new framework that exists to protect against service abuse. It works by extracting characteristics from API requests and then matching those against configurations that you make. So for example, you could set up a configuration that says you would like to allow 100 requests to a particular service method within the window of 5 minutes, and then have a separate quota for each client IP and user ID combination. So essentially, what you're getting is an average speed check. So you're protecting server resources. And with that, I'd like to hand back over to Jorge, who will talk about the next section of the talk.
Thank you, Stian. Pretty awesome, right? Okay, so once we have raised the level of security and control capabilities of Liferay, then this opens up the door to using Liferay as an API for frontiers beyond our trust levels, right? So, as I said, the JSON-WS APIs might not be the best for those type of scenarios. Fortunately, we already have JAX-RS, and we could have stopped there. We could have said, okay, you have JAX-RS. For those cases where JSON-WS is not good enough, build your own APIs. But we wanted to do better than that. So we're also working on a new breed of APIs on top of this JAX-RS infrastructure that we've introduced in the last version. So what are the capabilities that we were looking for? So obviously, we wanted those APIs to be useful for all these modern API needs, and also for all the different use cases that we're seeing today and tomorrow. So we wanted it to be useful for building mobile apps. We wanted it to be useful for microservices. Those are probably the two most common use cases nowadays. But also, we wanted to be ready for all types of devices, for all types of consumers, actually. Okay? So what do we think are the necessary characteristics for an API to be able to cover all of these cases. So we think there are 5 characteristics. One of them is the couple. I've already mentioned that that's the one characteristic that could be a problem of one of the characteristics of JSON WS. So that's the first one we need to tackle, right? Second one is it needs to be evolvable. So evolvable basically means that consumer and API can evolve separately, independently, without breaking each other. That's very important because it simplifies change management a lot. Otherwise, it's really, really hard. It has to be very easy to use. You're going to try to attract developers that you don't have a relationship with. So it has to be easy to use. Otherwise, it's just not going to happen. We also want these APIs to be customizable. That's more for you, for anyone building that API. JSON WS has a lot of benefits, but it's the way it is. And if that's not exactly what you want to expose to third-party developers, then you have to start from scratch with your own APIs. And even that infrastructure doesn't allow doing a lot of things. So if we are going to build a whole new set of APIs to make it easier, then it's important that they are customizable so that you don't have to rely on starting from scratch. And of course, it's very important that they are efficient. So let me go one by one on what we've done for each of them. So the couple. Again, why the couple? To allow reusing across Liferay versions, for example. Right now with JSON WS, because it's coupled, it's also coupled to one Liferay version. So it's really hard. There are ways, but it's really hard to have, for example, a mobile app that works for several versions. We want to attract developers that have nothing to, know nothing about Liferay, actually, and we want independent evolution. So the number one solution, or not the number one solution, but the key thing that we're doing to decouple is this concept of shared vocabularies. We've talked a little bit about it in the last couple of days. This is a concept that is genius. Unfortunately, we didn't make it up. It's probably the number one API expert in the world nowadays, Mike Amundsen, came up with this concept, shared vocabularies. Basically, what that means is your contract as an API provider with the consumers is a set of types, a set of attributes that you're saying, hey, this is what my API will expose at some point, right? And it's very well defined what it will provide. Actually, the next step is, okay, if we want to do this, why don't we standardize some of these types? And there are good news here as well, which is there are very well-defined standards already. The picture here is about schema.org. If you don't know, schema.org is a big effort by all the big browsers, started by Google, to create the standard vocabularies, standard types, and attribute definitions for all of the things that you can find on the internet. It doesn't cover everything, but everything you can find on the internet, which is a lot of things already, right? So what we've done for these APIs is we've used this as a base. We've used schema.org as a base of all of our types and attributes that we're going to expose through this new breed of APIs. Shared vocabularies doesn't limit yourself to just standards, because there are things that just are not covered by standards. For example, one API that we're working on that is not covered by schema.org is the workflow API, right? A workflow, a task is not something that you search up on the internet. So we're making up our own types and reusing attributes from schema.org, actually. So we don't have to reinvent the wheel, really, from scratch. So what does this mean? So basically, this means that you have our internal model, our internal tables, and we have to look in schema.org and map them. Here, it's block entries. There, it's a little bit more interesting, because in Liferay, we have two tables, user and contact, right? But that's internal. We don't want to expose that to the public. We may change our mind and say it's our database, our data model in the future. So in schema.org, they have one type, which is called person. So we do a mapping, and the user of the API doesn't have to be affected if it changes our internal data model. Okay, that's basically what it means. So second characteristics, be evolvable. Being evolvable means accepting you're going to make changes to your API. Don't break your consumers. So in order to make that possible, without imposing a lot of restrictions, you need to design your APIs in a certain way. So one key technology for achieving that is Hypermedia. Again, we've been talking about Hypermedia every day in a conference, yesterday, today. Why? What happened to us, what I think it's happening to most people is when you talk about Hypermedia and APIs, you say like, wow, really? Some people say, yeah, I've heard about it, but in practice, that's not doable. And what we found out is that it needs to go through a denial cycle until you fall in love with it, right? So hopefully today, some of you will get to that phase. So how many of you have used Hypermedia? Everybody. Okay, so most people are sleeping right now. Because all of you have used Hypermedia. Hypermedia is just the links that you use in your browser, the forms that you use in your browser. Every button, that's Hypermedia. So obviously, you might be thinking who has used Hypermedia in APIs. That's a harder question. Fewer people are using Hypermedia in APIs. So these are the key characteristics of using Hypermedia in APIs that differ from using Hypermedia in browsers. So first, the first point is really, really different. Your API right now is most probably a big documentation of lots of URLs, what you can do with each of those URLs. A full Hypermedia API, and you don't have to go full Hypermedia to benefit from it, but a full Hypermedia API just has one endpoint. And there are some standards already, like JSON Home, which became a standard a few weeks ago, I think, which provide information that your consumer can understand to continue traversing the rest of the API. Now, the one question that I get whenever I explain these Hypermedia and APIs is, wait, but a human sees a link, reads the text, and they know what to do with it. But if I need to write a program, that program is not going to know what to do with it. And that's where this concept of link relations are very, very important. And there are actually standards, like from IANA. IANA link relations explain it's like 40 or 50 types of link relations. Like, this is a search. This is how to add something. This is how to go to the next or to the last page. So let's see an example. This is an example of a response of a Hypermedia API. These words here, first, next, last, those are link relations that are standardized, right? So you can write your consumer to understand that first means the first page of a pagination, next means the next page, last, etc. Right? And there are 50 of these, and you can make up your own. That's perfectly fine. You can make up your own, and then what you do is your consumer understands that text, that word, that has a specific meaning for you. It doesn't have to remember the exact way of building the URL. It also applies to forms. Why hard code exactly in your mobile app, in your microservice at the other end of the network or the world? What are the exact fields of your entity? What if you want to add a new field? What if you want to make a field required and it wasn't previously required? What is a better solution? You write the consumer so that it's able to read this simple information. This is very simple. It can get more complicated, like HTML forms, so that it knows how to adapt to any changes in the API. So basically, Hypermedia enables APIs and consumers to evolve independently. Why? Because now the consumer is not tied to a long list of URLs and what they can do with each of them. So this actually also contributes to the next point, which is how to make it easy to use. Why? Well, first, we are encapsulating all Liferay concepts because of the use of shared vocabularies. We're using REST and HTTP principles, which are well known. These are RESTful APIs. It simplifies the documentation a lot. Your documentation with this type of APIs, the documentation we're going to create, is not a long list. You can imagine how long that list would be for Liferay of URLs. We're going to document what are our types. And most of those types, we won't even have to document because they will not be our own. It would just be a list of types from schema.org that we are documenting, and that we are using, and we'll have to document the ones that are custom. And one thing that has amazed us the most is that you can actually do much more reuse than ever before. I'll go back to that in a minute. So again, we also wanted to make this customizable. So we are building these APIs in such a way that you can expose whatever you want. How are we doing that? Well, we're leveraging OSDI. It's pretty simple, right? So we're making it easier to build URLs to any resource that is already part of the API. And every resource is an OSDI component. So you can customize them and make only available the parts of the API, the specific resources that you want to expose to the end world. You can even make some more complicated things, such as depending on who is accessing the API, you may expose more or less. And it's more efficient. This is very important because sometimes the consumers are on a network and you don't want to consume extra bandwidth, or you don't want to use a lot of CPU and battery, right? How do we do that? Well, basically, we start by using HTTP caching very efficiently. We also give the consumers a lot of control. If any of you have used GraphQL, they're probably popularizing this concept, but it's not the only way of doing it, and we're also doing that. So the consumer can say, I need exactly this. I don't want to make 3, 4 different queries, and I don't want to get more data that I really need. And we're also allowing exchanging the different formats that we will support out of the box, and we'll support several out of the box, with something binary, such as protocol buffers. Okay? So I'm going to do a very quick demo of 1 minute, especially for those of you who were not yesterday in the DEVCON presentation, but I think it's worth seeing for everybody. So this is you accessing the initial endpoint. In this case, it's groups. The authorization is already there. It's basic. It could be OAuth 2. Then I've chosen a specific format, which is JSON-LD. And then I got the response in JSON-LD. So I have a lot of groups. Okay, there you can see the pagination. And I'm actually going to go to the next page here, because the group that I'm looking for, which is the default group in Liferay, guest, is actually in the second page, and I know that, right? So a system would just look for the group with the name guest, and it could paginate as desired. And then that group has blocks, has folders, and has something called web page elements. So I can, again, follow the link and see the list of blocks. And the list of blocks, once again, is paginated, right? So I have 13 elements, and I can look at one of them. And I can see that these fields are actually coming from schema.org. And I can see things such as ratings, or I can see the creator or the author, right? So going to the efficiency route, if I need to get the information about the creator, right now I will need to click on it. And that's another round trip. Right? We don't want that. So we're also making it possible so that actually the client can say, and this is an example manipulating the URL manually, but this could be automatic. I want the creator of the block entry to be embedded in the response. So now if we go back, we see that the creator is already in the initial response, and we don't have to do it again. This is very, very, very powerful. So this is how it's created. It's very simple. We've actually created some tooling on top of YaxRS to make it very easy. Here you declare the entities. Here you do the mapping of schema.org. And then you can build mobile apps. And we've built a mobile app along the way to test these new APIs. And what we've found out is that most of the code of that API is actually generic. It can be used for many, many other APIs. So we've created 2 things. One is called Vulkan Consumer, which is the lower level, and another one is a new screenlet called the Thing Screenlet that allows you to consume any Hypermedia API. It's not even limited to Liferay at all. So we think with this, the mission is accomplished. We will provide a new breed of APIs that achieve these 5 things, and will enable you to achieve these 5 things in your own APIs as well. So what is the plan forward? Well, we've already been building the infrastructure, and along the way, we're building the first set of APIs. Some of the APIs here, you can already find them on GitHub if you look it up. We want the first set of APIs, probably many more than what you see there, in 7.1 to be released next year. But we want, for the next release, or maybe even without waiting for the next release, comprehensive APIs for all of Liferay's capabilities, similar to what we have with JSON WS. So basically with this, we are adding new capabilities to Liferay, both on the security side and on the specific out-of-the-box APIs as well, with a strong control and many more characteristics that are useful for this new API economy. So finally, what we're trying to achieve here, I wanted to make this clear, is the freedom to choose when to use Liferay as headless, when to leverage the provided UI, or when to combine the 2. Our vision is not that Liferay is going to become only headless. We actually believe that the combination of 2 and the ability to progress between the 2 is actually what is the best strategy. Thank you.